Hello and welcome to another episode of Conservation Conversations with BirdLife South Africa. I'm your host, Melissa Whitecross, coming to you live from Johannesburg, South Africa. A big thank you to Christina Hagen for holding down the fort while Andrew de Block and I were out in Mozambique, working on expanding the Vulture Safe Zone network with our previous speaker, Linda van den Heefer. Tonight, it gives me great pleasure to welcome two bright young shining stars in the field of ornithology to your screens. At this year's virtual Learn About Birds or Lab conference, we awarded prizes for the best master's and PhD level presentations. And tonight, the winners of these illustrious awards will share their research with all of you in a layman's friendly way. But before I tell you more about Shamiso, Banda and Kailen Padayachee, please remember that you can communicate with us using the Zoom chat room, and questions for our speakers can be posted into the Q&A box throughout the webinar. If you're watching on Facebook Live, you can use the comment feed for your comments and questions, and we'll answer these at the end of the webinar. We're active on all social media channels, so please use the hashtag Conservation Conversations to get in touch with us. All of our previous episodes are available on the BirdLife South Africa YouTube channel, and a massive thank you to all of you who have subscribed to this channel. We managed to hit our 1,000 subscriber mark, and that has enabled us to start using this as a fundraising platform. So thank you to all of you who took the time to subscribe, and we encourage you to encourage all of your friends to come and subscribe to BirdLife's YouTube channel too. If you're enjoying the webinar series and can afford to support it financially, every little bit helps us to keep this webinar free for all to learn and enjoy about our amazing birds and their conservation. Simply scan the Quicket QR code on screen or visit our Conservation Conversations website to find the link to the donations portal. A big thank you to everyone who has donated thus far. There are less than 70 tickets left for our jackpot birding raffle. Make sure not to miss out on this opportunity to support conservation while standing a rather good chance of winning that 100,000 Rand cash prize. Head over to BirdLife South Africa's website and click on the jackpot birding tab. Our Conservation League donor competition is ending at the end of August, so you can show your commitment to conservation by signing up and stand a chance of winning a 4-night stay for two at the luxurious Zamanga Private Game Reserve in northern KwaZulu-Natal. This is valued at 40,000 Rand. So for more information, please email our membership team at membership@birdlife.org.za. We also have an exciting announcement about the popular South Africa Listers Club. Our much-awaited milestone pin badges are now available through our online store. That's right, BirdLife South Africa's online store is up and running. You can build up your South African flag as you progress through your list of milestones with our proudly South African colored pin badges. Reaching a milestone in your birding journey is an achievement worth celebrating. You can join BirdLife South Africa in celebrating birds and birding by joining the Listers Club through our website, and you can collect your special milestone badges as you go. Each badge is on sale at just 75 Rand and can be purchased at shop.birdlife.org.za. And you can pin those on your hat or your binoculars and show everybody just how well you're doing with your lists. Join BirdLife South Africa and Eco Training in the exclusive Makuleke area of Northern Kruger National Park for a birding weekend of epic proportions. We've opened up 2 weekends for bookings in November, arguably the best time of year to be birding this magical destination. You can expect twice daily drives and/or walks with expert bird and wildlife guides, specials such as the mouth-watering rack-tailed rollers, 3-banded courses, Hell's Fishing Owl, Arno's Chat, and more at an all-inclusive rate that will never be seen again. The second weekend includes the National Birding Big Day, which happens at the end of November, and visitors for this weekend will be treated to a full day of bird chasing, a list of mouth-watering birds for their lists. Make sure not to miss out on the limited spaces available and book through Wesley Abrams at projects@ecotraining.co.za. It now gives me great pleasure to welcome Shamiso Banda and Kailen Padayachee to tonight's show. Shamiso is currently completing her MSc at Nelson Mandela University and is part of the talented team at the Marine Apex Predator Research Unit. Her research is currently focused on the impacts of increasing temperatures on seabird diets, and she will share some of her results with us tonight. Shamiso describes herself as a lover of research with a passion for conservation and science communication. Joining Shamiso tonight is PhD student Kailen Padayachee. Kailen is the co-founder of the KaiNav Conservation Foundation, a non-profit conservation education organization based out of Johannesburg, South Africa. He's been involved in wildlife and environmental conservation for the past 14 years in various positions, from marine conservation intern with the South African Marine Biological Research Association to environmental and cultural educator with the Walt Disney World Company in the USA. After returning to South Africa, Kailen decided to further his career as a conservation biologist, receiving his MTech degree in nature conservation from TUT in Pretoria. He is currently completing a PhD at the FitzPatrick Institute at the University of Cape Town, focusing on raptor conservation and ecotoxicology. He's also an honorary research fellow at the University of Witwatersrand. And besides his academic career, Kailen's work in conservation through the KaiNav Conservation Foundation has been internationally recognized, with him being nominated as a Future for Nature Award finalist in 2020 and recognized as one of Africa's top 100 conservation leaders in 2021. He continues to guide the research and education programs at the foundation while completing his studies and serving on boards dedicated to wildlife and environmental conservation, including the Magaliesberg UNESCO Biosphere Reserve and the National Lead Task Team. A massive welcome to both of you. And once again, huge congratulations on winning the Best Presenter Awards at this year's Lab Conference. We'll start off with Shamiso's presentation, and then we're going to head off into Kailen's talk. Please remember, everybody, that you can post your questions while the presentations are playing, and we will tackle these at the end of the webinar. And while I load your talks, I'm going to allow Shamiso just to greet everybody and say hello, and then Kailen, you can say hello to everyone too. Thank you both for joining us.
Awesome. Hi, everyone. Very, very, very excited to be here. Very excited to just share some of my research with you all. I hope you managed to learn a little something about seabirds today. And yeah, looking forward to questions, please. If you have anything to ask, I am happy to provide answers.
Thanks, Shamiso. Kailen, over to you.
Hi, everybody. Thanks, Melissa, for that introduction. It's so good to see so many people joining in. Yeah, excited to be here. So if you have any questions, please fire away.
Brilliant. Looking forward to it. Thank you both. And we will get underway with your talks now.
Hello to everyone tuned in, and welcome to a talk titled What's on the Menu When We Turn Up the Heat. I'm Shamiso Banda, and I'll be your storyteller for the next couple of minutes. So, you may be wondering what this is really about. More specifically, I'm going to take you through a study which I conducted under the supervision of Professor Pierre Pistorius and Dr. Mayal Konan. The overall objective of the study was to find out whether warmer temperatures had an influence on the diet of this seabird. And off we go. I hope you have some snacks ready. So, for a bit of background knowledge, marine top predators, which includes seabirds, have been recognized as climate and ecosystem sentinels. Now, what this means is they are able to indicate when climate and ecosystem changes occur. This is because changes which occur lower in the food chain spread through the food web and end up being reflected as changes in the behavior and/or population sizes of marine top predators. So, when their behavior and population sizes are significantly altered, it shows us that some sort of alteration has occurred in the system. Let's consider the simple conceptual predator-prey relationship for a moment. This green zone is the best case scenario, where there's enough food, aka prey, to support each member of the population, aka the predators. When less food is available, we move to the red zone, where individuals may not be able to meet their energetic needs. A consequence of that would be that couples are unable to reproduce successfully, and if that happens, population sizes can be affected. Alternatively, some seabirds can change their behavior by feeding in different areas or on different prey species. Either way, both of those possible responses show that a change in the system has occurred. Here is an example of a case where warmer than normal sea surface temperatures caused a change in the diet of blue petrels, and then those dietary changes were found to negatively affect their breeding performance. At the moment, climate-driven changes in the Southern Ocean are having extensive impacts on marine ecosystems through such pathways. Now, this illustrates the very important relationship between diet, demography, and the environment. Different species may of course be affected differently, and it is therefore important to study as many individual species as possible. That brings us to our study species, our seabird and marine top predator of choice, the sooty albatross. So to begin with, their diet is mainly composed of cephalopods, specifically squid, which contribute up to approximately 80%. During their breeding season, they are central place foragers, and what this means is they leave the island to forage and then return back to the central place to feed their chicks. So much like going to the grocery store to buy food and then returning to your home. So because they have to return, they can only travel within a certain radius. So the sooty albatross is also an endangered species whose diet is poorly understood in terms of how it changes over time. The last comprehensive study of their dietary composition was about 26 years ago. So the best information on their diet before this particular study was a quarter of a century old. So, why study the diet of the sooty albatross over these 3 breeding seasons? I should start by saying a strong El Niño event occurred in 2015/16, and what this signifies is a period of uncommonly warm temperatures during the following year in the Southern Ocean. So essentially, the event occurring in 2015/16 led to the 2016/17 breeding season being warmer than it otherwise would have been. As such, it can be used as a proxy, a sort of test situation for future climatic conditions because warming is occurring. I will refer to this as a warming event for the rest of the talk. We know that environmental changes affect prey availability and wanted to test that in sooty albatrosses through their diet because it's important to assess responses to environmental changes considering the possible consequences on predator population sizes and parameters, and therefore ecosystems on a broader scale. Cephalopods are a major food source for millions of predators in the Southern Ocean, so understanding their vulnerability to warm temperatures is important for predicting and understanding how those predators might be impacted and how ecosystems, once again, are likely to change in the future. And this flows into advocating for the use of marine top predators as biosamplers, so essentially using these natural fishers instead of having to fish out the cephalopods ourselves. Now, overall, the overarching motivation was to understand the responses of both predators and prey, because this will help us develop a predictive understanding, which is what we should aim for to form proactive conservation strategies. This brings us to the specific research questions. Firstly, did diet change over the study period? And secondly, did the locations of where the birds forage or the trophic level fed at change over the study period? On to the methods, the techniques, and the data used to answer the research questions. Samples were collected from the sooty albatross population breeding on Marion Island during 3 breeding seasons, the 2015-16 breeding season to the 2017-18 breeding season. Now, this island is in the southern Indian Ocean and it is a special nature reserve under South African management. It's approximately 2,000 kilometers southeast of Cape Town, and it is a BirdLife International designated IBA, also known as an important bird area, because it's home to an estimated 8 million seabirds. Stomach contents were collected from chicks through spontaneous regurgitation. When these chicks are startled, they tend to vomit their food. This is a brief overview of the sample stomach analysis procedure. So firstly, diet samples are defrosted and weighed, and the volume of liquid is then measured. Contents are then separated into fresh items and accumulated items, which are those that have been in the stomach for a longer period. Squid beaks and the other components were then stored separately. And lastly, the prey items were identified down to species where possible using reference guides. All right, so the beaks were separated into upper and lower beaks, identified, of course, measured, and counted. The species composition of the diet and the sizes of the squid fed on were then compared between years. Let me know if you'd like to know the specific tests I used. For stable isotope analysis, to answer our second research question, blood samples were obtained from adults in November, December, and February, and all sample sizes are shown in these tables. Here is a brief schematic of the stable isotope analysis procedure. The three blood fractions, whole blood, red blood cells, and plasma, which inform on different timescales, were separated and dried, then powdered and sent to the light stable isotope lab at UCT for carbon and nitrogen isotope analysis. Now, the carbon isotope ratio informs on the feeding area, and nitrogen informs on the trophic level fed at. And of course, these ratios were then compared between years. On to the results section. What did we find? We'll begin with the diet. Cephalopods, aka the squid, were the dominant prey class each year. However, there were significantly less cephalopods in 2016, and this coincided with an increase in bird remains. So they ate much less squid and much more other birds during that year. This change could be reflective of the warmer conditions that year. And just to show how large the difference was, only 368 squid were recovered from the diet in 2016, compared to 2,104 in 2015 and 2,298 in 2017. A total of 8,516 beaks were isolated from the stomach contents. So that is 4,481 upper beaks and 4,035 lower beaks. And yes, I counted each and every one of them. This is really one of my favorite things to tell people. The number of different species and the quantity consumed was significantly different between the years as well. Once again, 2016 was different from 2015 and 2017. Now, two species specifically, B. scallops, which I will refer to as the blue squid, and G. glacialis, which I will refer to as the orange squid, were largely responsible for the dissimilarity between the years. There was a clear shift in dominance from the blue squid in 2015 to the orange squid in 2016, and then back to the blue squid in 2017. Another very interesting fact, or rather interesting finding, was that the relative contribution of species in 2015 and 2017 were almost completely identical. So almost the exact same amounts of the different species, besides a 0.1% difference in Condocovia longimana. Otherwise, the two would have been completely identical. On to a comparison of sizes fed on. Here there was a significant difference in the sizes of the blue squid fed on. So specifically, More smaller squid were consumed in 2015 and 2017 compared to the warmer year 2016. For the orange squid, however, similar sizes were consumed between the years. This graph here speaks to the locations fed at as well as the trophic level fed at. And in a nutshell, it shows that these albatrosses foraged in similar waters between these 2 years. That's to say there was high overlap between the years. And these results show that there was a dietary change without a change in the foraging zone. And we can now come full circle and answer the questions we set out to find. So firstly, were there changes in the diet? Yes, there most certainly were. Did the foraging zones and the trophic level fed at change? No, those did not change. Thus, the dietary change was not because the birds fed in different areas between the years, but was a reflection of a change in squid availability during warmer conditions. Now, this kind of change in availability can occur for several reasons, like these studies have suggested or shown. One is that some species may grow faster than usual, or species may migrate to cooler temperatures where they're more comfortable. Either way, we know that a reduction in prey can have negative consequences on their predators. To conclude, dietary changes suggest that the cephalopod species are sensitive to warm environmental conditions, and in the face of climate change, this may have important consequences for the species whose diet is mainly composed of cephalopods. And once again, biosampling has proven to be a useful tool for knowledge generation. Such a nice way to say that all in all, the forecast is we're all going to die and there'll be no one left to remember our stories. No. Brad Pitt and I are joking. There's still a lot we can and will and should do. We know that all these magnificent creatures are being impacted by climate change. Climate change also sounds like a pretty big issue to tackle, but one way we can work against it is by protecting our oceans, which includes the animals that live within it. Much like the rainforest, the ocean is an important carbon sink and it's in trouble at the moment. So, I would like to end this with a recommendation to watch Seaspiracy on Netflix if you haven't already. It's a really great look at the current state of our oceans, and it's a real eye-opener about the fishing industry's impact on biodiversity. That is it from me. Thank you so much for listening.
Good evening, everyone. My name is Kailen Padayachee, and tonight we'll be discussing temporal and spatial patterns of organochlorine pesticide analysis in raptors globally. This study forms part of a much larger project to understand how certain organochlorine pesticides have been monitored throughout the world using birds of prey. For this presentation, we wanted to summarize existing knowledge on one of the most destructive and possibly most extensively studied OCPs in history, DDT. DDT is probably one of the most notorious pesticides ever created, and while its disruptive impact on wildlife may be common knowledge, the origin of this compound may not be. DDT was first synthesized in 1874 by Austrian graduate student Ottmar Seidler. However, it was only 66 years later, in 1939, that the extraordinary insecticidal properties of DDT were discovered by Swiss-born chemist Paul Müller. This discovery coincided with the start of World War II, which presented the perfect opportunity to make DDT's world debut. The powerful insecticide was implemented to protect thousands of soldiers against vector-borne diseases such as typhus and malaria, a task at which DDT was staggeringly effective and historically successful. With the end of the war in 1945, DDT became widely available to the public as an agricultural pesticide. However, it was during the 1940s that scientists first started voicing their concerns regarding the negative impacts DDT posed to the environment. Nevertheless, the role this compound played in saving lives during World War II earned Müller a Nobel Prize in 1948. Peak DDT use was reached between the 1960s and 1970s. However, 1962 saw a significant turning point in the way the public and scientific communities saw this miracle compound. Rachel Carson's book, Silent Spring, was published in 1962, sparking incredible public outcry and bringing the irrefutable danger posed by OCPs to the fore. As a result of the growing evidence, the United States banned DDT in 1970. Most European countries soon followed the United States, banning DDT in the 1980s. 32 years after being banned in the Northern Hemisphere, the Stockholm Convention on Persistent Organic Pollutants, adopted by over 90 nations, came into force, restricting DDT in most parts of the world. This convention also restricted another 11 POPs, dubbing them the Dirty Dozen, due to their significant threat and persistence in the environment. 2 years later, however, the World Health Organization decided to support the reintroduction and use of DDT, specifically in certain tropical countries, to control vector-borne diseases, particularly malaria. This resulted in the legal production, distribution, and use of DDT in many Asian and African countries. It's evident from this timeline that DDT has long been impacting the environment, and its effect on organisms are well known, considered responsible for catastrophic declines in raptor populations across the globe in particular. However, it's important to note that several scientists believe that it was in fact the combined impact of both DDT and another one of the Dirty Dozen, dieldrin, that led to these dramatic declines in northern raptor populations. They postulate that DDT, specifically its metabolite DDE, induced significant eggshell thinning, resulting in reproductive failure. This reproductive failure was then exacerbated by mortality of adult birds due to dieldrin contamination, which further depressed population growth, leading to significant declines in these populations over time. While pre-1960s and 70s population data on many raptors in relation to OCP contamination is limited, there are some indications from certain populations, specifically in the global north, during the time of DDT use and after subsequent bans and restrictions. We see this in the study from Helen et al. On white-tailed sea eagles. They show that mean productivity in sea eagles increased as DDE concentration in eggshells decreased between 1965 and 2005. This is just one of hundreds of published studies since scientists first started investigating OCPs in raptors. Individual studies like this, covering a limited geographical region and only a few species at a time, while valuable, provides equally limited data. Hence the need and importance to consolidate all that we have discovered over the decades. Such an abundance of data has the potential to provide a substantial understanding surrounding DDT contamination in global raptor populations over a considerable time period. However, to do so requires a formal, structured method that can summarize and synthesize what has already been done and discovered so far. In order to accomplish this, we used a systematic review to search for, gather, and appraise relevant published studies on DDT and dieldrin in birds of prey from around the world using a set of specific keywords. The aim of this review is simply to synthesize our current knowledge on these compounds in global raptor populations. Our systematic search of the Web of Science databases produced 481 potential studies. After examining the titles, 241 of these studies were excluded. Abstracts from the remaining 240 studies were examined and 16 more excluded. The 224 studies left were examined in full and included in the review. An additional 38 studies cited in these selected studies were reviewed, and 5 of which were excluded, resulting in 257 studies that met our inclusion criteria. The 257 studies were published between 1966 and 2020 and represented all continents except Antarctica, providing data on DDT and dieldrin in 30,698 individual raptors of 115 different species spanning over 115 years, from 1901 to 2016. Our first point of call was to understand which parts of the world were most represented by this vast amount of data. In other words, which continents are published studies focusing on the most? We found that 88% of these studies represented just North America and Europe. The remaining continents were represented by only 12% of studies. Now keep in mind that Australia and New Zealand were the only countries represented from Oceania, both of which represent the global north. And while only 6% of studies represented Asia, certain countries such as Japan and Russia are considered to be part of the global north. All this means that more than 90% of published studies represented the global north, and less than 10% represented the global south. In terms of temporal disparity, we found that most studies were published in the 2000s, with 87% of these studies once again representing just North America and Europe. Furthermore, while North America and Europe were represented in studies as early as the 1960s, it took a full decade for the rest of the world to receive similar attention in publications regarding DDT and dieldrin contamination in raptors. Once uncovering this bias in publications, we turned our attention to potential disparity in sampling. Once again, we discovered that 96% of all raptors sampled were sampled from just North America and Europe. The top 3 species sampled globally, Eurasian sparrowhawk, bald eagle, and peregrine falcon, accounted for almost half of all samples, with only the peregrine falcon being sampled across all continents, albeit being sampled at substantially lower numbers in the global south. Most data on DDT and dieldrin contamination in raptors comes from raptors that prey predominantly on birds. Other foraging gills that may be expected to yield substantial information on pesticide contamination, such as invertebrate specialists, have largely been excluded from such analyses. After looking at species sampled, we thought it would be interesting to look at tissues, and whether the preference for certain tissue samples differed through time. We found that eggs were sampled the most, accounting for 40% of all samples, with the oldest egg being collected in 1901 and the most recent being collected in 2013. We found that eggs, possibly not surprisingly, have been consistently sampled over the last 115 years, unlike other tissues which were only sampled regularly from around 1962. In fact, between 1901 and the early 1960s, eggs were the only raptor tissue being assessed for both DDT and dieldrin. By consolidating 115 years of information on DDT in global raptors, we have uncovered considerable spatial knowledge gaps. The Northern Hemisphere, particularly Europe and North America, has received most of the attention when it comes to OCPs in raptors. Here we show the number of studies published in the top 6 countries from which most of the knowledge on DDT in raptors stems. You can see that except for the United Kingdom, most of the information on DDT in raptors not only comes from the global north, but from after the implementation of bans in these respective countries. Current legislation and conventions have thus been largely geared from that perspective. However, the introduction of DDT in particular has been implemented in countries from continents that have comparatively less data on these OCPs in raptors. So, with what we now know, could OCPs like DDT still pose a risk in the face of all these strict global restrictions? Well, we know that India, for example, is still a significant producer and user of DDT and was recorded using a staggering 3,092 metric tons in 2014 alone, being responsible for 84% of global use during this period. India also exports DDT to countries in Africa and the rest of Asia as both technical product and formulation. South Africa receives technical product and creates DDT formulation for local use and export to other African countries. In 2014, 1 other Asian country and 7 African countries reported their DDT use. However, 5 more, while not formally reporting use, were recorded by independent data as having used DDT. It's important to note that all this information is from known data. It is still unclear how much DDT use goes unreported, particularly in Africa, Asia, and South America. This is largely due to major shortcomings in national reporting procedures. All this information sparks a renewed urgency to assess OCPs in raptor populations from these lesser studied continents. So what's next for this study? Well, we'll be conducting a meta-analysis to statistically test changes in DDT and dieldrin in global raptor populations. In addition, we plan to test changes of these OCPs in eggs of global raptors as the most commonly sampled tissue for analyzing these compounds. Smith conducted a similar exercise for human breast milk with very interesting results, and we aim to produce data and graphs similar to that study, quantifying DDT and deodorant concentrations over time and geographic locations. Finally, we're making use of the Amur falcon carcasses from that catastrophic die-off that most of you may have heard about in 2019. This is meant to provide a more current assessment of OCPs and raptors. This should shed some light on the contamination of a migratory species which occur across both northern and southern hemispheres in countries currently using and or producing DDT in particular. Samples are currently being analyzed in Spain at UCLM's Institute for Game and Wildlife Research under the guidance of Dr. Rafael Mateo. And with that, I would like to thank all of you for attending this talk, and to all the organizations and individuals that have made this study possible and continue supporting this project.
Thank you so much, Kailen and Shamiso. Those were absolutely phenomenal talks, and I'll invite both of you to join me on screen so that we can tackle some of the incredible questions coming through from our audience this evening. I certainly learned a whole lot, and a massive thank you to both of you for all of the effort that you have put into those talks tonight. I see we've got a number of different questions, and I see Shamiso had a bit of a head start to answer all of them. Shamiso, if you are able to put your camera on, that would be great, but no worries if your internet is playing up. But I think we'll start off with you, and I know you have typed some questions into some of these answers already, but I think it'll be good for our audience who haven't had a chance to have a look at the answers, just to answer some of these too. So I think we're going to start off with the question that Dieter asked, and this is actually something I jotted down to ask you too, and that was regarding the breeding population of city albatrosses across these different years. And obviously with this shift in diet and these warmer seasons, what's happening to those breeding birds? If you wouldn't mind just telling everyone what you answered there, please.
Oh, okay. So I added there that we don't actually have the breeding population data, so we don't have those population counts, unfortunately, because I would also love to know what's happening there. I'd love to get my hands on that. But yes, sadly, that is the current answer. I do hope they're doing well, though. And that does tie into another question asked. I'm sorry, I didn't get the name down, but someone asked if the chicks were also different weights between the years. And I thought, well, that's a fantastic question, because if the chicks were doing fine, then that's a potential sign that the population would be fine even during warmer temperatures. So yeah, definitely something to look into, and I hope someone does. Maybe
absolutely. Maybe the topic for your future PhD, go and spend some time on Marion catching city albatross chicks. And I see Andrew, just following on Shamiso, Kailen will come to you in a second. Andrew Marshall's asking, do you know if the two squid species moved their distributions based on the fluctuating temperature variations? And can you talk to this a little bit?
Okay. So again, we can't exactly say, because we didn't sample the squid directly. So we can only, sort of make suggestions based on what we saw in the diet. However, from the literature on cephalopods and what's known about them, they are very sensitive to changes in environmental conditions, and they either respond to warming temperatures by shifting their distribution, like Andrew suggested, or by growing quicker than they otherwise would, which is why that size difference was really interesting, because it sort of suggests that when these birds went to feed, the cephalopods that were there were either larger than they otherwise would be or smaller than they otherwise would be. So there's definitely a change in the population there.
Fantastic, and lots more questions to be carried out by the amazing research team out there. All right, Kailen, we're going to cut across to some pesticides for a moment, and we'll come back to you in a moment, Shamiso. I see Penny Abbott's asked a question around the use of DDT, and she says that it's no longer used for wide-scale spraying, and she thinks that it's rather used for limited indoor spraying. Is that true, and does your current study take this change into account?
Yes, so in South Africa, we do allow for what's called IRS, or indoor residual spraying. Our study wasn't aimed at quantifying anything like that. The study, or at least this part of my study, looked specifically at synthesizing what has been done with regards to monitoring of DDT and raptors globally, and to kind of understand where are we at the moment. Give us, give a bit of a historical retrospective on this on the topic. And the idea is, we've got a number of these bans and restrictions, and there's conventions dedicated to it. But the majority of information used to set up these bans and these restrictions have come primarily from the global north, from places like North America and Europe. However, places in the global south, like Africa, or South Africa in particular, are given permission to use it. Do we have enough information on it? And it suggests that, there's a huge gap. We don't have a ton of research as we do in the north, in the global north, to make these types of decisions. And that was kind of where we were going with this piece of research.
Fantastic. And I see Kudazi, also asked whether DDT is still regarded as the most effective pesticide for combating vector-borne diseases. So if you wouldn't mind just chatting around that for our audience, please.
Yeah, so unfortunately, yes. Currently, DDT is still widely regarded as the most effective pesticide for combating vector-borne diseases. Hence why countries, specifically your tropical countries, are still to a certain extent allowed to use this compound. But there are other considered less, not so much dangerous, but less persistent pesticides that can be used, and that's the biggest problem with DDT, is the persistence in the environment. We're picking it up years and years later, even in places like North America and Europe, where it's been banned for so many years. We're still picking up traces of it, and that's the issue that we're dealing with here. But yes, short answer is yes, it is still very effective, and no, there isn't anything that has been discovered yet that can replace it completely.
Absolutely. Thanks, Kailen. And I see there was a comment around dildrin, and I forgive my pronunciation of that. But Hendrik is asking, do you have convincing evidence of dildrin causing or associated with eggshell thinning? Would you mind just sharing what you answered to that, please?
Sure. So dildrin is actually not associated with eggshell thinning, and that's not, it never has been. But a lot of scientists believe that it was the eggshell thinning in a lot of these raptors that were studied wasn't enough to cause that dramatic decline alone. It was rather the adult mortality caused by chronic dildrin contamination, in concert with the effect DDT, specifically DDE, has on productivity of these birds. So the thinning of the eggshells causing breakages of the eggs, in concert with the die-off of adults, that combine to kind of give us that huge decline in birds, in bird populations that we saw in the north, specifically the peregrine falcon, which everybody DDT is synonymous with now. So yes, it doesn't cause eggshell thinning, but it adds to the issue.
Absolutely. And I see just a comment from Bonnie on behalf of Peter Mundy, who's tuning in this evening, and it's great to have you both tuning in. Peter's saying that in tropical countries, the half-life of DDT is very short, which is obviously helpful. So that is good to know. And thanks, Peter, for that comment. And Ted's sort of asking, sorry, Kailen, we're just going to continue on this egg thinning theme. Do the birds of prey also suffer from egg thinning more widely when it comes to DDT exposures? So of the sort of studies that you looked at, was egg thinning synonymous across your birds of prey?
Yes, when it comes to DDT in raptors, yeah, that was the biggest thing that a lot of researchers looked at. It was specific species, so mainly your aquatic species, osprey, bald eagles in the north. A lot of the papers that studied eggshell thinning came from those particular species.
Fantastic. Thanks, Kailen. Shamiso, we're going to jump back to you for a little bit. Obviously, you and Brad Pitt had some not so great news for us at the end of that talk, but can you talk a little bit around what the sort of predictions are for El Nino going forward? I mean, we know this is quite a variable system, and it's something that's only really been kind of mainstreamed in the more recent decades. But Dita's sort of asking, would this shift in diet be sustainable if the temperatures around Marion were to shift permanently to a more warm state?
Ooh, would the shift in diet be sustainable? I'm not exactly sure what that question even means.
I suppose would the breeding success continue, which we don't necessarily have the answers for yet.
Yeah, again, we would have to see how the shift affects the population as it is now for us to make, you know, those kind of predictions. Yeah, but as we've seen, some species will do well under warming conditions and others not so much. So it's a winner or loser scenario at the moment.
Fair enough. And I saw you had a category for birds in your dietary analysis. Now, this is something I didn't realize albatrosses partook of the feathered varietals. So I learned something this evening. Did you manage to identify which birds they were eating?
They were mostly prions based on a lot of the feathers, but in some cases they were penguins as well. Yeah, it was not pretty.
Fascinating. I learned something tonight. I had no idea. I thought they were mainly piscivorous. So thank you. Always good to learn something on the show. And Kailen, we're going to jump back to you. Sorry, Ted, I bungled your question, but he's asking not necessarily the birds of prey, but the prey that the birds of prey are eating. Do we know if there's any impacts on them with regard to DDT exposure?
Okay, so I'm actually not sure about that. From our study, we only included papers that looked or focused specifically on birds of prey, and at that, wild birds of prey. However, I do know of a few papers that did experiments using chickens, and I believe, I stand to correction, I believe that the chickens did display a certain level of eggshell thinning with DDT or DDE. So possibly it's across the board, yes.
Definitely. And I suppose I see we've got a question or more comment from Shashi here, Kailen. And Shashi is saying that it said that DDT saved about 500 million lives based on the US National Academy of Sciences in 1970. And the toxic effects are well documented. But what's your take on this dichotomy? And I guess it really comes down to, do we conserve us or do we conserve biodiversity? And where do we find that middle ground? Do you want to weigh in on that contentious comment?
It is a contentious comment, and it's one of those questions that we have to ask ourselves, right? Yes, it is toxic and it is persistent in the environment, but yes, we can't deny that it did save lives. And I mean, that's why Paul Muller, the scientist that actually developed it or synthesized DDT those many years ago, actually won a Nobel Prize for it because of the amount of lives it saved. So yes, I think we have to find a balance. We do. The fact of the matter is, pesticides, all types of pesticides, have positively influenced our lives. You know, in terms of food security and disease control, that is a fact. But we need to be able to strike a balance, because while DDT, if we look specifically at DDT, while it is saving lives, we do have evidence that not only our wildlife, not only our wildlife is being affected by it, but humans too. There's evidence of neurological and endocrine disorders linked directly to DDT use in parts of the world. So yes, it is something that we need to be cognizant of, and just kind of strike a balance where we can.
Absolutely. And I think that's something that all of these ethical discussions we're having, not just in conservation, but birding in general, are leading to discussions around that. So certainly thanks, Kailen, for that weighing in. And I see Peter Mundy has also chipped in once again. Thanks, Peter. Game birds are resistant to the effects of DDT. So that's always a plus. And We're going to jump back one last question to Shamiso before I start to wrap things up this evening. I see Dieter's asking if cities would be able to feed on prions as a larger part of their diet if the waters do warm. Shamiso, do you want to weigh on that?
The question being, would they be able to?
Yeah, shift their diet towards a more bird-focused diet.
Ooh, wow, hard to say. I'm not sure what the energetic value of these prions is versus the cephalopods that they're used to. We have seen cases where seabirds are able to sort of shift their diet or shift their prey according to what's available within their foraging range, just because they simply have to eat something. I'm hoping it doesn't get to that, and I'm not sure if it would be sustainable for the prions as well. But yeah, it's really a wait and see situation.
Absolutely. And one more question before I start to close it. I see we've got a question around how much plastic was in the city albatross diet, and I know that takes us down a whole rabbit hole. But did you come across any plastics in your analyses? These are obviously birds on a fairly remote Southern Ocean island. What did you encounter?
Okay, sure enough, there was plastic in their diet, sadly. A lot of the times it was unidentifiable, so it would be sort of little pieces of something. You can tell it was once part of something larger, but not quite what that something was. In some cases, I did find chip wrappers, which looked like they were of Asian origin just because of the text on the wrappers. But yeah, their plastic is somehow making its way there.
The ever-pervasive plastics. Well, we're not going to delve into that tonight, but I must just say to both of you a massive thank you. This has been phenomenal and fascinating, and I think we could definitely talk about both of your studies for a lot longer this evening. But I see Dieter's just asked whether your studies will be available online. I know you are both still in your studentships and currently analyzing and furiously writing up your theses. So I'll give each of you a chance just to share your contact details so that anybody listening can get in touch with you if they do have questions. And also when you sort of predict to hopefully have this out in the mainstream scientific world. So Shamiso, we'll start with you and then go over to Kailen.
Okay, well, I'm reachable through my email address, which is banda.shamiso@gmail.com, but I'll just put that in the chat box for whoever would like that. As for the outputs, well, manuscripts are in preparation, so hopefully this should be published early next year or maybe later this year. But yeah, please be on the lookout.
Fantastic. Thanks, Shamiso. Kailen?
Yeah, so I'll also put my email down in the chat, kailen@knavconservation.org. But yes, currently busy writing up the manuscript, the first chapter, which in fact this talk forms part is about that first chapter. So hopefully that would be available after we go through the publication process in the next year or so, hopefully less. But yeah, you can always reach out on that email, and I'll be happy to answer any questions.
Brilliant. Thank you both so much. It has been an absolute privilege bringing you onto the show, and I'm so excited to see where African ornithology is going with the two of you and your amazing young colleagues coming through the ranks. It is phenomenal to see the kinds of research that are being put out by our South African ornithologists. So wishing you both everything of the best in your academic journeys and all of the exciting roads ahead, and best of luck with those publications. We'll certainly look forward to reading those when they do ultimately come out. So thank you both. Before I let you just give any closing statements, just a reminder, everybody listening, there will be a post-webinar survey, and we are asking a couple of questions around the webinar formats. So we'd really appreciate your insights and thoughts on how we can improve the show and make it a good listener experience for all of you. And please also be sure to tune in next week. We're going to be doing the best of the Virtual African Bird Fair. There'll be a bit of a cameo role between Andrew, Christina, and myself, and showcasing some of the talks that were on offer at this year's Virtual African Bird Fair. So please do join in with all of us. And before I wrap things up, I'm going to give each of you just a chance to say any closing sentiments. So we'll start off with Shamiso and then Kailen, over to you.
Closing sentiments, okay. Mostly just thank you to everyone that tuned in. I really appreciate it. I almost had a heart attack when people started saying they couldn't hear me, because it's something I'm so used to when giving live presentations, just because my voice is so soft. But I hope that you got something out of it. I hope it was somehow beneficial. And thanks again.
Absolutely, and this will be available on YouTube. So if you did miss out on any of the sound issues, we'll make sure that that YouTube recording is loud enough for everybody to hear. Kailen, over to you.
Yeah, just a big thanks to everybody for joining and listening in. Thanks for all your questions. I know a lot of folks that have been supporting this research and me in my academic career over the last few years have actually joined in. So thank you to you all. And as always, if you have any questions, reach out and let me know.
Brilliant. Thank you, Kailen. And with that, a massive thank you to both of you. All of the effort you put into those talks was outstanding and really great to have you on the show. And congratulations once again on winning Best Presenters at the Learn About Birds conference. And we look forward to seeing follow-up talks at the future virtual labs for all of this exciting research. So with that, a massive thank you to all of you for tuning in. I will see you this time next week in our usual slot, 7 o'clock every Tuesday on Conservation Conversations with BirdLife South Africa. Thank you so much for joining us. Keep your eyes on the skies, keep enjoying those birds, and I'll see you next week, everybody. Good night and stay safe.